The TOP 500 project ranks and details the 500 most powerful non-distributed computer systems in the world. The project was started in 1993 and publishes an updated list of the supercomputers twice a year. The first of these updates always coincides with the International Supercomputing Conference in June, and the second is presented at the ACM/IEEE Supercomputing Conference in November. The project aims to provide a reliable basis for tracking and detecting trends in high-performance computing and bases rankings on HPL, a portable implementation of the high-performance LINPACK benchmark written in Fortran for distributed memory computers. China currently dominates the list with 229 supercomputers, leading the second-place United States by a record margin of 121. Since June 2018, the American Summit is the world's most powerful supercomputer, reaching 143.5 petaflops on the LINPACK benchmarks. The TOP 500 list is compiled by Jack Dongara of the University of Tennessee, Knoxville, Eric Strohmeyer and Horst Simon of the National Energy Research Scientific Computing Center and Lawrence Berkeley National Laboratory and from 1993 until his death in 2014, Hans Moyer of the University of Mannheim, Germany. History. In the early 1990s, a new definition of supercomputer was needed to produce meaningful statistics. After experimenting with metrics based on processor count in 1992, the idea arose at the University of Mannheim to use a detailed listing of installed systems as the basis. In early 1993, Jack Dongara was persuaded to join the project with his LINPACK benchmarks. A first test version was produced in May 1993, partly based on data available on the Internet, including the following sources. List of the world's most powerful computing sites, maintained by Gunter Arendt. David Kahner, the director of the Asian Technology Information Program (ATIP), published a report in 1992, titled, Kahner Report on Supercomputer in Japan, which had an immense amount of data. The information from those sources was used for the first two lists. Since June 1993, the TOP 500 is produced biannually based on site and vendor submissions only. Since 1993, performance of the number one ranked position has grown steadily in accordance with Moore's law, doubling roughly every 14 months. As of June 2018, Summit was fastest with an R-peak of 187.6593 petaflops. For comparison, this is over 1,432,513 times faster than the connection machine CM-5 1024 cores, which was the fastest system in November 1993, 25 years prior, with an R-peak of 131.0 gigaflops. Topic: Architecture and operating systems. In June 2016, a Chinese computer made the top based on SW26010 processors, a new, radically modified, model in the Sunway or Shenway line, while since US-based computer overtook it, and by now two US-based are above it. As of November 2018, TOP 500 supercomputers are now all 64-bit, mostly based on x86-64 CPUs, Intel EMT64 and AMD 64 instruction set architecture, with few exceptions, all based on reduced instruction set computing (RISC) architectures, including 13 supercomputers based on Power architecture used by IBM Power microprocessors, 6 SPARC, all with Fujitsu-designed SPARC chips, one of which, the K computer, surprisingly made the top in 2011 without a GPU, currently ranked 18th, while only dropping to 3rd on the HPCG list, and 2, seemingly related, Chinese designs, the Shenway-based ranked 11 in 2011, ranked 158th in November 2016, and Sunway SW26010-based ranked 1 in 2016, making up the remainder. Another non-US design is PEZYSC, while it is an accelerator paired with Intel's Xeon. Two new computers appeared on the list in 2018 based on architectures not seen there before, while the former is just a new microarchitecture for x86. Thus in total AMD has 3 computers on the list, with one of its Opteron-based, that's much older, ranked way higher or 9th, from Chinese vendor Sugan. Hygon Diana-based CPUs collaboration of US AMD and Chinese is ranked 38th, and the first ever ARM-based computer on the list, using Cavium Thundix 2 CPUs, also appeared on the list in November 2018. Before the ascendance of 32-bit x86 and later 64-bit x86-64 in the early 2000s, a variety of RISC processor families made up most TOP 500 supercomputers, including RISC architectures such as SPARC, MIPS, PA-RISC, and Alpha. In recent years, heterogeneous computing, mostly using NVIDIA's graphics processing units (GPU) as coprocessors, has become a popular way to reach a better performance per watt ratio and higher absolute performance. It is almost required for good performance and to make the top or top 10, with some exceptions, such as the mentioned SPARC computer without any coprocessors. An x86-based coprocessor, Xeon Phi, has also been used. All the fastest supercomputers in the decades since the Earth Simulator supercomputer have used operating systems based on Linux. Since November 2017, all the listed supercomputers 100% of the performance share use an operating system based on the Linux kernel. Since November 2015, no computer on the list runs Windows. In November 2014, Windows Azure Cloud Computer was no longer on the list of fastest supercomputers. Its best rank was 165 in 2012, leaving the Shanghai Supercomputer Center's Magic Cube as the only Windows-based supercomputer on the list, until it also dropped off the list. It had been ranked 436 in its last appearance on the list released in June 2015, while its best rank was 11 in 2008. It has been well over a decade since MIPS-based systems, meaning used as host CPUs, dropped entirely off the list, but the Gyoukoi supercomputer that jumped to 4th place in November 2017 after a huge upgrade has MIPS as a small part of the coprocessors. Use of 2048 core coprocessors plus 8 times 6 core MIPS for each that no longer require to rely on an external Intel Xeon E5 host processor, make the supercomputer much more energy efficient than the other top 10, i.e. it is 5th on Green 500 and other such ZETTASCALER 2.2 based systems take first 3 spots. At 19.86 million cores, it is by far the biggest system, almost double that of the best many-core system in the TOP 500, the Chinese Sunway Taihulite, currently ranked 3rd. Top 500 ranking. Legend. Rank, position within the TOP 500 ranking. In the TOP 500 list table, the computers are ordered first by their Rmax value. In the case of equal performances Rmax value for different computers, the order is by Rpeak. For sites that have the same computer, the order is by memory size and then alphabetically. Rmax, the highest score measured using the LINPACK benchmarks suite. This is the number that is used to rank the computers. Measured in quadrillions of floating point operations per second, i.e., petaflops. Rpeak, this is the theoretical peak performance of the system. Measured in pflops. Name, some supercomputers are unique, at least on its location, and are thus named by their owner. Model, the computing platform as it is marketed. Processor, the instruction set architecture or processor microarchitecture. Interconnect, the interconnect between computing nodes. Vendor, the manufacturer of the platform and hardware. Site, the name of the facility operating the supercomputer. Country, the country in which the computer is located. Year, the year of installation or last major update. Operating system, the operating system that the computer uses. Other rankings. Top countries. Numbers below represent the number of computers in the TOP 500 that are in each of the listed countries. Systems ranked No. 1 since 1976 == IBM Summit, Oak Ridge National Laboratory, United States, June 2018 present. NRCPC Sunway Taihu Light, National Supercomputing Center in Wuxi, China, June 2016 to November 2017. NUDT Tianhe 2A, National Supercomputing Center of Guangzhou, China, June 2013 to June 2016. Cray Titan, Oak Ridge National Laboratory, United States, November 2012 to June 2013. IBM Sequoia Blue Gene Q, Lawrence Livermore National Laboratory, United States, June 2012 to November 2012. Fujitsu K Computer, Riken Advanced Institute for Computational Science, Japan, June 2011 to June 2012. NUDT Tianhe 1A, National Supercomputing Center of Tianjin, China, November 2010 to June 2011. Cray Jaguar, Oak Ridge National Laboratory, United States, November 2009 to November 2010. IBM Roadrunner, Los Alamos National Laboratory, United States, June 2008 to November 2009. IBM Blue Gene, L, Lawrence Livermore National Laboratory, United States, November 2004 to June 2008. NEC Earth Simulator Center, Japan, June 2002 to November 2004. IBM ASCI White, Lawrence Livermore National Laboratory, United States, November 2000 to June 2002. Intel ASCI Red, Sandia National Laboratories, United States, June 1997 to November 2000. Hitachi CP PAX, University of Tsukuba, Japan, November 1996 to June 1997. Hitachi State Route 2201, University of Tokyo, Japan, June 1996 to November 1996. Fujitsu Numerical Wind Tunnel, National Aerospace Laboratory of Japan, November 1994 to June 1996. Intel Paragon XP S140, Sandia National Laboratories, United States, June 1994 to November 1994. Fujitsu Numerical Wind Tunnel, National Aerospace Laboratory of Japan, November 1993 to June 1994. TMC CM5, Los Alamos National Laboratory, United States, June 1993 to November 1993. NEC SX-344, Japan, 1992–1993. Fujitsu VP 2610, Japan, 1990–1991. Cray YMP 832, United States, 1988–1989. Cray 2, United States, 1985 to 1987. Cray XMP, United States, 1983 to 1985. Cray 1, United States, 1976 to 1982. Topic: Number of systems. By number of systems as of November 2018. Topic: New developments in supercomputing. In November 2014, it was announced that the United States was developing two new supercomputers to exceed China's Tianhe-2 in its place as world's fastest supercomputer. The two computers, Sierra and Summit, will each exceed Tianhe-2's 55 peak petaflops. Summit, the more powerful of the two, will deliver 150 to 300 peak petaflops. On 10 April 2015, U.S. government agencies banned selling chips, from NVIDIA, to supercomputing centers in China as acting contrary to the national security interests of the United States, and Intel Corporation from providing Xeon chips to China due to their use, according to the U.S., in researching nuclear weapons, research to which U.S. export control law bans U.S. companies from contributing. The Department of Commerce refused, saying it was concerned about nuclear research being done with the machine. On 29 July 2015, President Obama signed an executive order creating a national strategic computing initiative calling for the accelerated development of an exascale 1000 petaflop system and funding research into post-semiconductor computing. In June 2016, Japanese firm Fujitsu announced at the International Supercomputing Conference that its future exascale supercomputer will feature processors of its own design that implement the ARMv8 architecture. The flagship 2020 program, by Fujitsu for RIKEN, plans to break the exaflops barrier by 2020, and it looks like China and France have a chance to do so, and that the United States is content, for the moment at least, to wait until 2023 to break through the exaflops barrier. These processes will also implement extensions to the ARMv8 architecture equivalent to HPC ACE2 that Fujitsu is developing with ARM Holdings. Inspur has been one of the largest HPC system manufacturer based out of Jinan, China. As of May 2017, Inspur has become the third manufacturer to have manufactured 64-way system, a record which has been previously mastered by IBM and HP. The company has registered over $10 billion in revenues and have successfully provided a number of HPC systems to countries outside China such as Sudan, Zimbabwe, Saudi Arabia, Venezuela. Inspur was also a major technology partner behind both the supercomputers from China, namely TIANHE2 and Taihu, which lead the top 2 positions of top 500 supercomputer list up to November 2017. Inspur and Supermicro released a few platforms aimed at HPC using GPU such as Senior AI and AGX2 in May 2017. Large machines not on the list. Some major systems are not listed on the list. The largest example is the NCSA's Blue Waters, which publicly announced the decision not to participate in the list because they do not feel it accurately indicates the ability for any system to be able to do useful work. Other organizations decide not to list systems for security and/or commercial competitiveness reasons. Additional purpose-built machines that are not capable or do not run the benchmark were not included, such as RIKEN MDG-RAPE3 and MDG-RAPE4. Computers and architectures that have dropped off the list. IBM Roadrunner is no longer on the list, nor is any other using the Cell coprocessor, or PowerXL. Although Itanium-based systems reached second rank in 2004, none now remain. Similarly, non-SIMD-style vector processors NEC-based such as the Earth simulator that was fastest in 2002 have also fallen off the list. Also, the Sun Starfire computers that occupied many spots in the past now no longer appear. The last non-Linux computers on the list, the 2X1s, running on POWER7 in July 2017 ranked 494th and 495th, originally 86th and 85th, dropped off the list in November 2017. See also: LINPACK benchmarks, computer science, computing, Graph 500, Green 500, HPC Challenge benchmark, instructions per second.